Hello, hello. Welcome. Okay, this is you're joining me on my very first night of live streaming. We are going to make an AI art generator from scratch using just CUDA libraries and the standard library. And among CUDA libraries, we won't use any deep learning libraries. We're going to code all of the low-level functionality of a deep learning training process and neural network implementation ourselves. So let's get started. We'll start with installation. So this is how we'll have all the tools we need by the end of this. So this might take a little while. First off, we'll get Visual Studio Code. Okay, I'm on Windows. Every tool I'm about to install works on Linux. They work well. I've used all of them on Linux before. It's very similar between Linux and Windows. I'm just using Windows because I like Windows a lot. And I've seen better CUDA error messages on Windows. Haven't looked into why that is. Download VS Code. We'll start with VS Code. The other tools kind of take a while, so we can be on VS Code and configure that while we get our other tools downloaded, installation started. We definitely want to start menu folder. No desktop icon. Open with code action. Yes. Yeah, file context and directory context. Supported file types, that'd be good, and path, we want that. Okay. 1 second. Just trying to see if I get any chat messages coming in. My other computer. All right, we'll go ahead and launch VS Code. I've already had it installed, so it actually saved the last text file I had open before I uninstalled it. That's interesting. Oh, well, I uninstalled it, reinstalled it, and all my extensions are back. I've used all of these extensions. So I'll just go over which ones we'll need for this project, or that I recommend at least. Delete these error messages. Better comments is really good. The way you get to the extensions, it'll be here on the left. I have some extra icons here because I have other extensions installed. You can get to it by just holding down Control-Shift-X. And boom, opens extensions. So I'll do that again. Here's like a file explorer, essentially, where you can explore your project. We don't have a folder open. We'll do that later. This search will search within the entire directory that you have open. And if it's just one file you have open, it'll only search within that one. Unless you have a directory open, then it'll search everywhere. So yeah, from any menu we're in, or even if we're in a new file, Control-Shift-X, we want the C++ extension by Microsoft. So you come over here, click enable or install. The extension pack installs a bunch of extensions, but we don't need all of those. Okay, then next, there's one CMake. There's a one that Microsoft makes, so that's the, oh, let's enable it. That's the one, that's the good one. This one's like really not that great. We'll want a CUDA extension. Where's our, oh, here we go. Insight Visual Studio Code Edition. So you would hit install here. Yeah, I'll show you guys what it looks like if you don't have it installed. Install. It's pretty quick. This will let you navigate through your CUDA code the way you can with the C++ extension and navigate through regular C++ files. In case you don't know, CUDA is a way to program your GPU so you can run your code directly on your graphics card. The way a graphics card runs code is a bit different than a CPU would. So it's got like some custom calls, custom syntax that goes along with it. With CUDA, there's a few languages that they have APIs for. I'd say they're more than API because they add syntax and keywords to the language. But I'll be doing a lot of CUDA coding. There's CUDA available for C++, C, Fortran. I don't know about Python. Might be a few others, but those are the big ones. I know you can link in CUDA to run through Python. I don't know if you have to write the CUDA in C and then build a library and then call it through Python. However, Python bounds to C. That might be how you have to do it. Maybe it can be written directly in Python. I'm not, haven't used Python much, so I don't know. Then we'll want to Git tools. So Git lens is awesome. I'll reload. You don't have to reload. I just had to reload because I uninstalled and reinstalled it. A fresh install won't need that. Git lens. It's a great tool, especially good for looking at diffs between different commits. And of course, I'll be uploading this code to GitHub, so we'll get this official GitHub pull requested issues. I've never seen this switch to pre-release version, but I'm sure it'll work fine. Okay, next is to-do tree. This one's great. It'll go through your code, and anywhere there's a to-do in it, it will highlight it so you can see it. And then what it does is it creates like a new icon on the left-hand pane here. And anywhere in your code, it'll list the file name and all the to-dos and any text that comes after the to-do. There's a few others we might use, but I'll install those as we use them. Oh, here's another one. Number monger. This one's sweet. Okay, check this out. So in Visual Studio Code, this is what you can do just by default is you hold Alt-Shift, click anywhere on your screen, and now you have what's called a block select. So when you type things in, it types on all of the lines for you. And you might have a number of signals that you have. You actually might do something like this in CUDA. I know you're probably thinking that, oh, in C++ you just create an array. That's obvious. But in CUDA, there's actually reasons to do this. You can't create arrays on the stack. So in the stack is the fastest. The stack goes into the L1 cache on NVIDIA graphics cards. So it's actually better to make all of the variables that you have individual and not an array. So signal number, this is where the magic happens with number monger. Let me make sure I have it installed and it's enabled. Yep. Okay, back to the file. Control-Shift-P to open up the settings. And I think, what is it? A sequence, I think is how you would call it. Yep, insert sequence. And you can start it at any number you want. So just for sake of example, start it at 4. Step size we'll do 3. I don't remember what right align does. 0 pad, yes, we want to 0 pad it typically. Boom. Now it starts at 4, goes up by 3, all the way. This is really useful all the time. Like, just I use this all the time. I use other programs, like I might use Excel and then transfer in something as a CSV, do that operation, and transfer it back to an Excel file. It's really useful. Okay, so the next tool we'll get is Visual Studio Community. Visual Studio is a great IDE. It's way better than Eclipse. I've used Eclipse a lot. But Visual Studio Code, it's open source, it's by Microsoft. It's got so many additional great extensions put onto it. It must have some kind of like great extension creation API on it. That every company I've been to so far, almost everybody switched to VS Code. There's also, for people that are into Vim, which I am not, I respect those that are. This program has a Vim emulator, so you can use, I don't think every keyboard shortcut, but most of them. Okay, we'll do community. The reason we're using Visual Studio is because it comes with a compiler that works on Windows. And then we can have the CUDA compiler works with the Visual Studio one, MSVC. You have to have Visual Studio installed before you install CUDA, the CUDA compiler. So we're going to be waiting a little bit for this to install. We're doing CUDA C++. So before we install CUDA, we need Visual Studio and the C++ extension. We need any of this. We can always come back and install more things. Oh, I'm going to install this for myself. You don't need this. All right, so here we go. You might have to open Visual Studio 2 before you install CUDA, but it won't hurt, so better safe than sorry. Okay, next we'll be downloading CMake. CMake is a tool that helps the compiler know where all of your code files are and find all of them and compile them and link them all together. It also, you can put like define statements in, you can do preprocessor things through CMake. This one is very much used in industry as well. The use CMake, it generates a make file, which does everything I just said. And then you run them, after you run CMake, you get your make file, then you run the make file. The problem with make files is they're pretty unreadable. CMake's a lot easier to learn, it's more intuitive. So download for Windows. We don't need the source. 3.25. Oh, coming out with newer ones all the time. It's reverse compatible. So if you have a project that was built with CMake 3.13, for instance, this 3.25 will be able to generate your makefile for you. Makefile is usually what you target. You can also generate Ninja build files, but we'll do make. Make's more common. Ninja's faster though. You can probably tell by the name. Next, accept. Yes, we'll add it to the path. Default's a no, but we want it on the path, that's for sure. That was just my system prompting me to click yes for admin permissions for the install. Let's check that and put it on the path. So I just, you can't see because it's off screen, but I hit the Windows key so that the pane pops up. Then I just typed in environment. Well, you can just type in environment. And it should say edit the system environment variables, hit enter. And then this pops up for you. So it pops up straight to the advanced tab. Click environment variables, and on this is the one that should have it. I don't see it. Path variable. Maybe it's under system variables. No, it's not here. Well, let's see if it works. Okay, so I'm gonna open the command prompt, hit the Windows key, just CMD, enter. So it should be able to find that executable, because it should be able to, it should have its path listed somewhere, and then -- version will just tell us the version it is. Oh, it can find it even though it's not in here. I don't know how that works. Oh, we got it installed. That's good. Visual Studio's almost done. All right, next we'll install Git for Windows. So I'll slow down a little bit. Okay, so you go to Google, just type in Git, hit enter, click download for Windows. And we want 64-bit Git. We will get the setup, not the portable. I think that'll give us more options. I mean, more tools. Admin permissions. This is our first screen. There's a lot of tools that come with Git. So I uninstalled Git already, so I'm reinstalling it. That's why I'm getting this. You shouldn't see this. I don't like my icons on the desktop. I would just hit the Windows key and then type in the name of the program. So no, not on the desktop. Windows Explorer integration, yes, please. Don't have to check for updates. So I'm just leaving all these as default. Okay, so next. Default is good here. Next. Let's just use VS Code as Git's default editor. Oh yeah, there. Yeah, the default Git was written by the guy that wrote Linux, Linus Torvalds, and he made the default branch name master. But yeah, that's kind of weird because it's like people don't want to be reminded of slavery in the middle of their workday like 15 times. Yeah, main's a good default branch name. I don't know why they say it's a more inclusive name. I don't think most people want to be reminded of slavery. Get it from the command line. Yeah, we want to be able to use Git from their Windows command prompt. Yeah, we want to use this. There's a lot of instructions and stuff online on how to use OpenSSH. I don't know the difference between these. I'll go with the default. Commit Unix styles. That's fine. Okay, yeah, we'll use minTTY. There's a new Windows terminal. Or command prompt. That came with Windows 11. You can install it on Windows. I hope it's a lot better. I know it's got tabs at least, but there's some other things I could improve. Haven't looked into it. Okay, we'll do default git pull. Okay, that's done. Yeah, I don't really know what those last few options were. If anybody could add in the comments or into the chat what their personal favorite is. I'd appreciate that. All right, we'll launch it. No release notes. All right, we've got it installed. Looks like it's up to date. Visual Studio here. Let's open it up. I need to change this so you guys can see my Windows pane. When I hit the Windows key, I just type in Visual Studio. The installer is the one that pops up. So you can hit space 2022, and then now I have selected Visual Studio 2022. So I'll open that up. We're just doing this to make sure it's initialized properly. That might be necessary for the CUDA installs. Oh, sign in. So you have to have a Microsoft account, but you can use Gmail to do that. So that's convenient for me. And that's why my keyboard's out of frame for my password. All right, it's opened up. And I had it uninstalled. I just reinstalled it. I've got a few projects already. And that's the last we'll deal with that. Oh, yeah, that plus, so for VS Code, let's pin that to the taskbar. All right, now our last tool is CUDA. This is a big download. So 12.0 should be the latest one. Let's see if we need an account. I have a NVIDIA account, so we'll be fine. So Windows 10. I'll just do a local install. 3.4 gigabytes to software folder and open upon completion. Damn! I love these high speeds. So you can open up the terminal while we download this. We'll go over VS Code somewhere. VS Code, hold down Control and you press the tilde. That's the just left of the one. Well, I guess you would hold Shift for tilde, but so it's the accent aigu. So Control accent aigu, and then the terminal pops up. And this is the same. Oh, this is a PowerShell terminal actually by default now, which is similar to the command prompt. It's got more functionality. I haven't used PowerShell much, but I know that much. So let's see if we got Git. Yes, we have Git. That's good. I don't know what window dialog means. All right, let's open it. It was set to auto open. That must have been what that window dialog was. Here we go. Okay, user account control. Oh, I clicked it twice, so it came up twice. So I just hit yes once and then no. Okay, yeah, temp path to put all the CUDA files. All right, the floating screen's up. Here we go. Don't need these anymore. Alright, this is taking a while. Let's get back to the software stuff. Multitasking time. So me under my... Sorry, I'm nothing too illegal over here. Okay, we're good. Under my home folder, which I named Mick H. I'll let you guess what that stands for. I have a repos folder, and in that I have my various repos. So let's get started and we'll make our directory structure for our project. What should we name it? This will be the name of the repo for it. AI art generator. Sounds good. Alright, F2 to rename. I'm just highlighting it to copy it. Enter. New folder, Control Shift N, Control V, put the name back in. Okay, so this will be our root directory, and I like to put my source in a folder that's the same name of the repo. And then here I would have like my main file, and then a bunch of different directories for however I want to categorize all of our other files that we'll tie together. So I know, for instance, I'll have a folder for utilities that I make. We can just make our main.cpp file. And this will get full pretty soon. Okay, now to use CMake, we need to make a text file, and we have no control over this. It must be named CMake lists.txt, and I'm pretty sure it's case sensitive, so that's capital C, capital M, AKE, capital LISTS.txt. That's, yeah, all we should need for now. There'll be some files generated when we make it into a Git. So well, actually, while we're still on this subject, we can open this in code now because we selected the directory explorer menu. Oh yeah, and if you want to know why my color theme looks so cool, I installed a theme. It's an extension you have to get. So Control-Shift-X, that allows this particular theme. Cyberpunk, that's what it is. So you install the Cyberpunk extension here, and then you Control-Shift-P to open the settings menu, color theme, and then activate Umbra protocols should come up. I really wish it didn't save all of my settings, so I could know for sure that's how you do it, but it's something like that. I'm just fixing these errors. Alright, agree and continue. Let's do custom. Let's see what we get. Yeah, we might need these drivers. Oh yeah, also I've got I'm using a gaming card like 99% of people versus like a workstation card like a Quadro or a server card like a Tesla. So you can use GeForce Experience. That'll keep your driver up to date. I don't know if they put in like a different driver if you use CUDA or not. USB-C driver. Why in the world do they have that? Oh, it's gonna install this GeForce Experience. It's not going to because I already have it, but it would. Yes, this is what we're looking for. VS Code integration. Don't be brave and click it on and off like me. Just keep it on. Libraries. Oh, yeah, we want the visual profiler. We could be using that. And we want the samples. Oh, that's probably in the demo suite. You know, we're gonna do this all by hand. We don't even need to install these. Oh, we do need CUDA. We don't need the fast Fourier transforms and linear algebra. Where's QDNN? Get rid of that. Pooh, we're gonna do this like gangsters from the lowest level. As far as profiling goes, it's really good in regular Visual Studio. It's really weird. Microsoft named their IDE Visual Studio, and then they made a new text editor with like that extension API. They named that Visual Studio Code. So like Googling questions about either is a nightmare now. But usually I'll just try searching VS Code on Google. A lot of people just start calling it that now to like clear up that confusion. I haven't used the profiling in VS Code. Okay, yeah, GPU and kernel state inspection. Sweet. That'll be great for debugging. Kernel breakpoints. Syntax highlighting is nice. It has new syntax beyond the standard C++. CUDA supports pretty much everything in C++ except for exceptions. And one of their engineers came out and said that like none of the big companies have even asked for exception support, so they're not bothering with it. Which is fine by me. Alright, it's gonna launch GeForce Experience, which I did have installed, so I didn't have any problems with it uninstalling and reinstalling it. And there's a driver update. I'll download. I'm not going to install it because that's going to mess up my stream. We'll make sure there's no problems with downloading. There we go. All right, and no, don't click it. Close. All right, here we go. So earlier we opened up, went to our folder, right click, open with code, and it's open. So just to test our program, first we'll just test C++, and we'll do CUDA. So let's write a quick little program. All right, that'll do it. We'll go to CMake lists. This is a compatibility. The first line in every CMake file, you probably have comments, I don't know, but the first command, CMake minimum required. So this won't run because different, this could be transferred to different computers and they could have different versions of CMake. So you want to use the earliest version of CMake. So we have 3.25 installed, but you want to use the earliest version of CMake that could run your program, meaning like you don't have any new commands that are only in later versions. So CMake, they added a bunch of CUDA features in 3.17, and we want to use those. So we will use 3.17. So anyone on 3.17, 3.18, 3.19 will be able to run this. CMake language. So CXX, that's how they do C++. We're not going to do C. So we'll just, are we gonna, no, we're not going to do C. So just CXS XX for C++ and CUDA. All right, and then now we have our project name. So I always just name it what the repo's named. Project. Let me look up. I don't remember. I think it's add target. But we want to, we're not making a library. This is where we're telling it. Basically, we're going to make an executable here. Oh, there we go. Add executable. And I think it's like CMake project name. Yeah. Looks good. We got to add. Now we'll put in our, we've got to tell it which files we're compiling. So how do we do that again? Maybe it's an add executable. Let me double check. I got some other repos we can look at. Oh yeah, in the future we will make this so this is going on a Git repo. It'll be public so everyone can get it. I'm gonna make it cross-compatible with Linux. There's a huge advantage to Linux. There's no watchdog timer, meaning or there is one, but you can turn it off on Linux really easily. What that means is that like if you don't get a response from your GPU for 5 seconds or more on Windows, it'll like throw an error because it thinks that the graphics card is frozen. So it's trying to recover from that, which is great if you're gaming. But when we train the network, it's depending on how our algorithm will turn out to be. It's possible the GPU will do a lot of computation and not need any information from the CPU's RAM. So it could run for over 5 seconds without communicating back with the CPU. I've had this issue before. What I had to do is I would just transfer a single bool from the CPU to the GPU like every second. So like 1 byte. But I had to shut down all of my kernels, and then so then it has to end all of those threads, and then it has to like create a whole new context after sending the bool over, which isn't a big deal because it's once a second, right? It's not like once every for loop or so, but it made the code really messy, which I didn't like, having to stop my kernels like midway in some cases. And I had to do experimentation, like how far through the kernel could I get, and then it would change based on like how many threads I was using, like per block, and like how many total threads I was using across all blocks. So that's one advantage of Linux. Like I said, with Windows though, it tend to you get better error messages. I have no idea. It must be the drivers, but the NVIDIA drivers are closed sourced for gaming GPUs on Linux and Windows. So there's that's probably it's probably not gonna get any better for Linux with those error messages. Oh, we can put the languages. We put the languages in with the project name. Yeah, we don't need quotes with this. It's an executable, so I'll do. We're on Windows, so we'll do exe. Or wait, well, it'll probably automatically append exe since it's Windows. We'll see what happens. Okay, and we'll set our standards. We'll set the version of CXX we'll use, 17. That means C++ that was ratified by ISO in 2017. Same with CUDA. I think that just means it's a CUDA based off of C++ 17. We're not using OpenGL. We'll probably multi-thread. I'm not going to add anything in until we need it. Keep it clean. A lot of this is OpenGL stuff. Oh, and there's this GUI I was using in GUI for this other project. We won't use that yet if we do it all. We don't have any include directories yet. Oh, okay, this is how we do it. We just set sources. So set sources. Surprised they don't have a better, like a specific function for this. Maybe they do now. If there's a newer function, I would use that one. So we can look that up later. Here's where our file is. It's our only source file. What else we got here? Looks like we add the executable after setting our sources. That makes sense now that this sources is the oh yeah, after our sources variable is defined. Let's indent that. Yeah, so this would be a list if we had multiple lines of it, but it's just one line, so it's a typical variable. So I guess we could just put our sources here, like we could just list them out afterwards, but that's ugly. That must be why it's set like this. I still wish they had like a specific function for adding sources though. Okay, and then this means call what this variable is. This variable is set by the project command. This is anything that starts with like never name your variable starting with capitalized CMake underscore. These are because all of the reserved, not all of them, but most of the reserved keywords that CMake uses is prefended by that. Here's target sources. Okay, so I guess we could just use this to add in our files here. I'll get better at talking and coding. I've seen practice. Private. I don't know what private means, but we need it. So we'll comment that out, see if this works. We're not linking any libraries yet. The standard library is automatically linked in. This the DL, that's for dynamic linking. We don't need that. And multi-threading, this is a Linux windowing system. That's why it's the if Unix. But this doesn't have an if Unix. CMake has built-in functionality to find like all of your OpenGL libraries on your system if your system's supported. So I imagine that's Windows and Linux. Does Mac even support OpenGL anymore? I think I heard they don't. Oh yeah, okay, we want this in here just for reference later. We're not using our language C. So we'll delete the C section. don't want a C section. We want naturally implemented code. So here is where I could put in all my compiler settings that I would want to put in. We'll just delete all of these for now. And then not use any. We'll add them as we need them. Okay, we can specify specifically the CUDA architectures we want to compile before. When CUDA is compiled, it's compiled into a pseudo assembly language. And then it passes all of it, and so it takes out all the CUDA code, and then converts it to like the pseudo assembly language, and then it passes on the rest of this C++ code to the C++ compiler. And on initialization of the program, it passes that pseudo assembly code to the driver, and then the driver has its own compiler that actually compiles it to real like instructions, like machine instructions for the GPU to run. I think if you set these specific architectures though, it'll not compile it to ptax and just straight to the NVIDIA machine code. But we don't need that. Separate compilation, I don't remember what that means. Oh, and then we can set to if we debug is something that we can pass in when we run CMake. And so, for instance, so we could pass in debug and then make our CUDA language have the debug options. The capital G is debug for the CUDA compiler, which is NVCC. I think that's NVIDIA CUDA compiler. Okay, but we don't need to do that. So that should be it. Let's see if this works. Okay, we'll make a directory for our build. We'll cd into that build. Then we'll do cmake. And now it's not capitalized. Our source, so -s, we're telling it where our source is, and it's one directory above build. And where our build directory is, -B is in one dot. That means this directory. So 2 dots means one directory above. Single dot is this one. Okay, so we have an issue here. Let's see what this code says. CMake minimum required. Oh, we just have to put version. That's kind of silly. I don't know what other kind of argument this would possibly take. Close that. All right, what do we have here? Oh, the CUDA compiler directory is not set here. Define the CUDA property to resolve this. I also like Windows better because I can just hit Control C in the command prompt to copy things. I don't have to do Control Shift C. That throws me off a lot. Okay, so we could either just define this ourselves, so we could just, you know, set this variable to wherever the NVCC is. Or maybe we could just add it to the path. maybe. Okay, here we go. Alright, so we'll go Visual Studio 2022 community. And we're on a quest for NVCC. I know in Linux it's just called NVCC. Let's find out if it's called that in Windows. Hello. Oh, I use this tool called AstroGrep. On Windows, it's sweet. But you can search text within all kinds of files. You can search binary files. And you can also just search for names of files. And it's way faster than Windows search. Windows search is so weird. Look at this. So it's on Windows search details. It's finding all the exe files in this folder. And watch this. Let's let it find it. You can do it. Or it's finding all the files that have exe anywhere in the name. Okay, so it's found it now, and they're just like kind of randomly ordered. Or oh, or they're ordered by date modified maybe? Yeah, that's what it looks like. Might not be the case. Say you want to sort it by name. Oh, they fixed it. Oh no, yeah. So it has to research everything. No, it did it way faster that time. So maybe they did fix it. It used to, if you like sorted it in different ways, it would have to like research through all the files. It's kind of doing that, but it's faster. So maybe it. Okay. Hallelujah, they fixed that. That was really annoying to me. But so maybe AstroGrep's not faster anymore. We'll see. Actually, I'm pretty sure it's still faster though. Okay, Alt D to go to the URL. Well, actually, we can just check. Let's just search anything with exe in it. Yeah, that's way faster. Okay, so it is faster. It's not just the sorting problem in Windows that they fixed. See if it look boop, 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 boop. So fast. Okay, so we'll search for NVCC. This is just this is a wildcard search operator, meaning that 0 or more of any character. So we're searching for this, and then on either side can be 0 or more of any character. We could put it in the middle, and then it would still find NVCC, but it would also find anything with that has an NV in it and then a CC later. No, it didn't find it, but maybe this CMake file tells us where NVCC is. I do not want to open this in. There we go. Open it VS Code. Love ya. Lovely notepad, but just don't have the features I need anymore. I'm a power user. Oh, include directory. It's all a blur. Alright, so you get highlight it, just control F and I'll go up here. I search the whole file too. Okay, it sets it to this. But where is this defined? That must be somewhere else. Let's see, where is MVCC? No, not Nova. But this is on Linux. Windows. Oh, it's on the internet. Okay. CMake can't find CUDA. I know it's supposed to be MVCC, but I'm guessing what other people are Googling. Oh, this is Linux. Maybe if I restart. Yeah. Oh, there it is. C program files. NVIDIA GPU Computing Toolkit CUDA version 12. Then it should be in here, right? Yep, there it is. Maybe we just add this to the path. I mean, to the environment. Yeah, to the path variable. Tie it off. Okay, yeah, though it should be that. Okay, so Windows key CMD should be that any executable now in this folder should be able to be called. So I could just be able to do MVCC version. In Windows, I don't think you have to type in .exe. Yep, found it. Okay, so maybe CMake will just find it now. Let us hope. Nope. Where is okay? CMake -s. CMake error. Oh, okay, so it failed building this CUDA file. ID flag heater. Output was 1. Also, yeah, still directories blank. And it never tried to. Looks like it never did a test build for the C++ application. Okay, yeah, let's just try to set this. Alt D to get the URL, Control C. Boom. Let's do parentheses. Got some spaces in here. Yep. Nope. We have to do it before you say you're using CUDA. So you make 3 error parsons. Oh, they have to do that Windows thing. Oh yeah. Just double up the backslashes. Nope. Dude, it's old school. Google it. I get this error when trying to see make. Dang, he reinstalled everything. What a hero. Okay, what's the answer? Which that's a Linux command. Yeah, that's okay. Oh, what? We don't need that. Let's just remove CUDA and count that out. I want to make some progress. Boo! They've been written. Okay, so we'll go back to our folder. Look it up. In the build folder, we should have our. Oh shit! It's generating a Visual Studio project. That's what SLN is. It's for solution. We don't want that. How the F do I do this? Here. Using. Yeah, I'll just try to run this one. Let's see. I want to get the open this folder. Reveal in File Explorer. Just 2D. Open with code. Here we go. Just 2D. So we got our CMake here. Whoa. Whoa. I didn't tell you to. Oh, that's output. Alright, so dir. So we go to build. CMake -s here. One on directory above. Build is here. Visual Studio 16. Oh, okay. That's probably the last VS Code version I built it with. So I'll just delete. I think delete in on the command line in Windows is del. So we'll delete build. Delete the build folder. Make sure you want to continue. Yes to all. Okay. Yep, build's gone. All right, we made build. CD build. We're in the build. I'll hit up a few times. Oh, finds it here. This is also an SLN. So how do we build it then? Let's open at Visual Studio 22. I lied. We're back to Visual Studio. Yeah, no. Alright, so here's the thing, Bob. The whole project solution. Windows build C++, CMake. You might have to get MinGW in here. Or maybe when we do the CMake command, we'll tell it to not make a Visual Studio project. Look, this all building. This is the Jets 2D project, which outputs as controls.app. Yeah, so I just opened it in VS Code or Visual Studio, and now it's doing fine, compiling everything. Oh, this part's so annoying. I remember this. This is invalid. So I have these strings. I think they're printf statements, and I use %LLU for long unsigned, and that's gives me an error. Oh, it's sprintf. That gives me an error, or not an error, but like a note in Visual Studio. And on Linux, it doesn't. But then if I do it another way, then Linux gives me a warning, and then Visual Studio doesn't. So I went with the make it cleaner on Linux. Oh, yeah. I definitely want to cross compile with Linux. Check this out. I've got a Jetson Orin. I don't think it will focus on this. We'll check it. Here's a computer here. And if we feeling really fancy later, maybe I'll get sponsorship. We'll throw maybe a Tesla card in this PCIe slot. Hope you guys can hear that. But yep, I'm demanding sponsors. So yeah, this thing's got 32 gigabytes of RAM. It shares it between the CPU and the GPU. So we can recompile Ubuntu or some other flavor of Linux. Take off everything we don't need. Maybe use like 1 or 2 gigabytes, and we'll have a 30 gigabyte frame buffer. So for our neural networks, we could have a shitload of parameters on them. Let's see, yeah, with 30 gigabytes, that's 30 billion bytes. So we'd have like, if we use int 8, I don't know if we could use int 8, but if we use half floats, that'll be 15 billion parameters. That's a lot. I mean, there's gonna be some overhead for like training and stuff, but maybe like 10 billion parameters. Okay, so 2 builds succeeded, 1 skipped. All right, so we'll do all of this again with our current project build. I'm a little rusty on this stuff. I haven't been doing this lately. I'm in the embedded world at work. There we use ARM cross compilers and CMake. Okay, we got AI art generator. Made at C2P. Oh. Dang, 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 dang. Cannot find the release all build. I don't know what that's supposed to mean. Here's what we'll do. We will go on directory out, and we'll delete build again, and it's A for all years. Ha ha ha. Oh, can't do it. Probably because it's open here. Don't say. Cannot remove item. Ooh, not enough access rights, huh? How about now? Yes. All right. There it is. Okay, back here. CMake source one directory. Yep. Build here, please. All right. We'll go back to our directory. Build. I say where like you're following around. I'm going way too fast. It's all right. It'll absorb in. I'll run into same problems over and over. And you'll learn everything through osmosis. Now it's always a pain in the ass setting up a project, unless, well, no, yeah, it is always a pain. Yeah, setting up a project. Usually at a company, they just have one guy that's really, really good at it, and no one else has to deal with it. Okay. At my current company, I'm that guy. Oh, it says it succeeded. But one skipped. 2 succeeded, 1 skipped. I don't know why it's saying. It's like insinuating there's 3 builds. Okay. Build. Debug. Yep. Oh, here we go. Okay, if I just double click and run it, I think it'll just close automatically. So we will. Oh, if you hold shift and right click, I think. Yeah. We can open a PowerShell window here. You guys are learning the best tricks today. Yeah. Okay. So I just type in AI and then I hit tab. On Windows, it auto-completes just the first one that's like alphabetically arranged, which is kind of annoying, honestly, because sometimes you like don't notice there's another one with a similar like few letters. And you hit tab and then the wrong thing auto-completes. On Linux, it won't do that. It'll make a noise on Linux, and if you hit tab again, it'll like show you all the files and directories that start with that. Hello world. So it's building. So right now we're going into VS Code, and then we're building it. But we don't want to do that. We just want to do it all from the command line in VS Code. So let's figure that out. It'd also be nice to have CUDA. Okay. So I just realized we deleted the build folder. There might have been like some caching in there that was making it not find the NVCC. So let's just bring CUDA back and see if it'll do it for us now. No. There must be something in this CMake file. That is telling it to work. Ah, that's it. I didn't know. Yeah, there's the work command in here. Oh, we'll just copy and paste that over. Fix all our problems. Oh, yeah, let's give it. Let's have it output our project name. Oh, maybe because I have that in there now. Yeah, good thing I have this other project. I'll just delete this again. Build. Bye. Oh yeah. Gotta be. Apparently, explores the big dog way. Okay, yeah, let's close on Visual Studio. Alright, so build's gone, make dir build, cd build, cmake -s. Cmake determine compiler ID build. Okay, we'll just look back here. This seems like a different problem. Sea Lion, that's Mac. Okay, so they're having problems. I think Sea Lion's Mac. I like that name. CUDA 11. It's on Windows 10. Okay, so maybe we can have Sea Lion on Windows 10. Oh, he's doing MinGW. That's the good news. Like minimal GNU Windows, I think. But this is a GNU compiler. GNU is an open source nonprofit. They made the license that Linux uses. And it changed history in a really, really good way. Let's see if we're getting this. Output was 1. Okay, let's see if there's any answers here. Windows CUDA only works with a visual C. Oh, really? I didn't know that. Oh, you need, okay, so he's saying you need cl.exe in your path. This is from VS Code. I think the compiler though is MSVC. Maybe. Well, we got some time. Let's look at what the hell is this. What is this? Tool that controls Microsoft C++, MSVC, C, and C++ compilers and linker. Oh, maybe it stands for compiler linker. Or control something. Control ends in L. Okay, so we're here. We'll find cl.exe. What? Search subfolders. I mean, it's here though, isn't it? Unless it's like, yeah? No? Is it here? I'm crazy. I'll search the whole system. Oh, it said it in our thing here. I will just... Oh yeah, you can do a control F in here. I forgot about that. cl.exe. It is in here. I mean, that means our search tool is failing. Oh, I hate it when my tools fail. And this has brackets. This has those things the wrong way. We'll fix that. Whoop. Control N. Control H. Replace that with that. No regular extensions. Control Alt Enter. Boom. And the end, we'll just do this. We don't want that in there. And then I'll just make sure it's there. Okay, Alt D for the URL based. And cl.exe. There you are. Can I just like get the path? Kinda. Is it already just get the path? That'd be a cool like menu option. Maybe like some program could be made that would do that. Little utility. All right, back to environment variables. Oh yeah, by the way, if you ever change the environment variables for the changes to take effect, you have to close your command prompt. Path, edit. What? Yes. It did say, that guy did say just that it needs to be in the, just in the path, right? But you wouldn't have the executable in the path, you just have the directory to it. And this is from 2020, so it's a year and a half ago. Yeah, similar errors. He has this verbose flag. I don't think we had that. Did we? Memory test. Oh, ours is at the end. That's weird. There's not a semicolon between the temp and the dash V on ours. Okay. It's a work email. Good work email. Very good. Oh, okay. Well, you put it in there. Let's just adjust it. No distractions. Important. Oh, I didn't hit OK. I just exited. So it's not in there. And just so my computer has no excuses, we double check. Close this, change the path. And then you hit escape to clear out the, oh, yeah, to clear out your whole, anything you type in here. You could have a bunch of spaces. You just hit escape, it all goes away. On Linux, it's Control U. All right, we want my computer to have no excuses, and this won't take too long to do. So delete build. I wonder if there's like, if with the delete command, can I just put in something like a letter, a dash letter? So I have to do this second thing. They're not let us delete it without being an explorer. I'll never figure that mystery out. I don't want to. Okay, source is one directory above. Build here. I'll make a batch script for this, by the way. Dang. It just needs MVCC. CL. Oh, okay, yeah, it's just taking the C compiler and passing this CUDA. That's what the problem is. It should be taking... Or maybe this is something... This is part of the MVCC process. But I mean, it's just running cl.exe with all these options. Show includes. CUDA version 12.0. I guess it's including the include path. There must be like a include right here. Yep. There's a CUDA include files. Boop. Okay, bin. And the link. Profiler prune. I don't know what that is. PT Zas. That's that pseudo assembly. I think I called it ptax earlier. It's PTX ISA. Pizzazz. Pizzazz. Putzazz. Point sass. I wish that was a better. It's like an acronym. I don't want to say PTXAS all the time. All right, let's just stare blankly. CUDA toolkit. Property result. Okay, fine. I don't wanna set this. Now the toolkit directory. Would that be the bin file? Well, this says toolkit in the directory name, so let's just assume that that's correct. No, that's the correct one. Okay, so select that, Control L, and then Alt L, then it only like observes what you have selected. I just think of it as like lines, Alt L, even though, because usually you have the entire lines highlighted, even though it doesn't necessarily have to be that. You could have like half line selected. Oh, Alt L, probably highlighted. That's a good way to remember it. Okay, so we'll take the single backslash, do place out with double backslashes, and we make sure that it's not doing regular expressions. Is that would it work? Yep. Say it doesn't work. Okay. Okay. Delete -A. Let's see if that works. No. Maybe A means all of system or something. Don't want to mess around with that delete command. Could be deleterious. Okay. Source. The computer thing failed here. Do we still have that one thing where it says, yeah, it says CUDA directory does not exist. You know what? Oh, I don't want to restart my computer. Well, but the other CMake program's working. I mean, this is definitely using CUDA. Look at that. It's a CUDA. I'm not bullshitting you guys. See you right there. Right there. F12. This is a. I'll show you guys. That's how you know it's a CUDA file. Oh, yeah, you can navigate. You can go back and forth in your code with your mouse buttons. But I love it. But there's a secret to it. You have to set going back in code to alt left and going forward to alt right. We'll do the set sources thing like this does. Set sources. Set sources. Set sail. Yeah, to the parentheses. I mean the curly braces. Let's get rid of this. We don't have link libraries. Okay, so we have add executable, and then this should just be a bunch of stuff we don't need to worry about. Target link libraries, there's no library, just compile options, no compile options. Oh, mate, well. Oh, what if. Maybe that's what CUDA separable compilation does. It makes it function. They should call it CUDA functional compilation. If that is indeed the problem. I wonder what happens if you try to delete a folder in a batch file. And instead of this, like the yes to all things. We'll look at that later. Alright, make dir build cd build. Build file. Make sure this is saved. Oh yeah, that's a problem with the editor. I don't. It like never auto saves it. Like when you build it. VS, you can set Visual Studio. It either does it. I'm pretty sure Visual Studio does it by default. If not, I know you can set it to do that. Another pro tip. To find the keyboard shortcut. You can save all to Control Shift S, and then just randomly press Control Shift S like between keys. Between every single letter you type, just Control Shift S. Okay, we'll add this here. In the interest of time, we'll just make it. Der building. Make the build. What am I doing? I'll just up. Oh, I've had this terminal open. Oh man, kill terminal. That's probably the issue. Oh, thank God. That was a problem. I was about to delete this whole stream. Maybe this is a problem. I guess I don't know for sure yet. So, del, make the build. Well, I'm happy it's not that dumb of an issue. For sure, it's only now a chance it's that dumb of an issue. It could be a really complicated issue that we're going to help a lot of people out by figuring out. So he's doing this from VS or Visual Studio the whole time. Properties, configure common, edit custom set to with the Linux style directory delimiters. I wonder, is it still making our SLN file? It is not. Okay, step number 15. Oh, but what directory was it though? Oh, he has it with the version without the bin. Why didn't we try that yet? I should have tried the bin too by now. CMake list. Well, I'll just do CUDA. Whatever the heck it was. Yeah. Or define the property. Set CUDA toolkit. This is weird. Usually it would start with like a CMake. Oh, toolkit B12 dir. I should have known to put that in. Let's get that right there. How does it even know to look for 12? How does it know that I have 12 on here? It knows it here. I'm setting this like right here. Cool, paste. Maybe this is. I've never used Visual Studio 2022 before. This is an old question, but it's got a problem. This is not C mixed up. I don't want to just make a project from scratch in Visual Studio, because that'll be really, really hard to make it cross compile. It's kind of fine right now to just have it create a Visual Studio project and then open it and build it, because then I can also just generate make in Linux and build it that way. But eventually we'll get rid of Visual Studio altogether. CUDA toolkit. There's another one. There's set CMake CUDA compiler. Tool. And then we'll go to bin. Here's something I do. I hit F2, Control A, Control C, Alt D, Alt D, and dash bam, boom, bop. So I put it in the backslash and then hit Control V, and now I got the whole path here. It's gonna be a better way to do that. Do Shift left click. No, can copy as path. Does that work? Okay, so just ASCF. Just copy that. So shift right click. Shift right click. Copy as path. And then boom. Voila. There we go. Figured it out. CMake CUDA compiler. Boom. And then Control H, Alt L. So it's only what I'm selecting. Highlighted. Highlighted. Caps lock is on. It's off now. Okay. Single backslash to 2. Control Alt Enter. Build pad. Yeah, maybe setting this so it'll just throw in that .cu file. CMake CUDA compiler ID .cu. Well, here's the difference. I had the C. That's not gonna fix anything. Oh. Compiler IBC. Go here on. Boop. CUDArt static lib. CUDArt is whoa, what the hell? You can just select that. I can just drag it around. Is that one from one of my extensions? It's hard to see with all this. Check this out. All right, you just boop. I've got generator selected, and then I can just drag it wherever I want. Look, now it's gone from here and it's here. I don't know if that's standard behavior or not. I bet Notepad doesn't have it. Notepad. Oh, you don't know anything. Definitely does not work. Confirmed. Notepad. Oh, I'll set the CUDA architectures. So I've got the 1660 Ti. Let's see, 61 is the 1080 Ti. That's Pascal. 16 is like Turing, but without the tensor cores, which is the 20 series. I don't remember which one that is. Must be one of these three. Let's just make a batch file. Let's start here, and then I like to start it with numbers, so I can autocomplete it. CMake Windows .batch. Or I'll do Windows first, so that like it's easier to see at a glance. CMake. And so we're starting from this directory, so I'll delete build, and then make dir build, then we'll cd into build, and I think this would work like it does in Linux, where it actually, now this script file is like in that folder. Then we'll do cmake s sources in one directory above, and build is there. Let's see, do I need to like make it runnable? I don't know what this means in Linux. You can see. Let's just make sure the delete works. Windows delete directory batch file. What? Why does it have two? Oh, RD is just short for remove directory. Okay, well we'll just do rmdir, because then it's easier for the user to follow, like another user. So rmdir build, the whole tree, and what was the other one? Q? Yeah, Q for quiet. Okay, then uses the standard Windows directory delimiter. All right, let's run this. Okay, now this will be a quicker process from now on. All right, still with the MVCC errors. Okay, it finds the CUDA compiler here. Still says it can't find the CUDA toolkit v12 directory. Let's see, when we build it with our other project, is it using CUDA? Yeah, computer compiler identification is NVIDIA 12. So what the fuck? So I have this other project here that is building in CUDA that I made a long time ago. And it's a CMake file. If I run this CMake, if I run command CMake to run on this file, it'll successfully generate a Visual Studio project that you just open up and then it builds it. And then on this CMake file, I have things similar, but it's not working. Oh, I guess I'll put this in. We'll need that later. These defines will get rid of our some errors that we'll have with the standard library. And that's before I add the executable. Adding compile options for the CUDA compiler is not going to fix this either. Might as well try. Oh, we can do this all fast now because of our batch file. Sometimes on CMake, in the build folder where it puts all of its configuration information, it'll cache things. And so you might fix every single problem you have, but the cache to speed things up, it like stores data and it can be out of date, unfortunately. So it's better to always just delete your build folder if you're in the middle of dealing with CMake issues. CMake CUDA compiler ID.cu failed. Oh, I remember. There's like a CMake thing where you can skip the test build. Skip test build CMake. Okay, this doesn't answer my question. That's not gonna work. C test. How to skip test. How does it word exactly? Well, I don't know how to do it, but if we could just find the root of this, because it should actually pass the test field anyways. Alright, we'll do an exact phrase search. Then we'll do Windows. Try to install root with CUDA support. So what issues? This is Linux. See, here all he needs is a compiler on Linux. Apparently, you need the toolkit directory on Windows as well as a compiler location. So this is helps. Okay, so Visual Studio 2017. CMake Cookbook by Eric Songyuk. Where's the coworkers when I need them? CUDA compiler. Clang on Visual Studio. No help at all. Let's just start from the basics. Alright, build CUDA project on Windows with CMake. Oh, here we go. 2021. Yeah, we got a kernel here. Yeah, we'll just copy this in. Enable language CUDA. We could try that. Oh, this is Ubuntu. Damn it. Missed that. This is what we need. This is from 2017. Damn, they support a lot of compilers. CUDA C++ works on all of these? Alright, here we go. Oh, you know what? Maybe I won't set the standard C++ and CUDA, and oh, it says fatal error. That sounds serious. We're serious here. Yeah, I guess instead of extracting this, I'll just put it in there. What if the problem was I just don't have like a kernel in my code? I'm gonna try to do this from memory. And then I think the type goes after global. Oh, it won't work because it's not a .cu file. Let's make it. Never. Let's make the CU file. I see you. I've got the CUDA extension installed, so I don't know why this is showing an error. I'll double check what that guy was saying about he want to. Where was that? There we go. Yeah, I had it right. Oh, I didn't have 2 1s in the input. I don't know if you need that. Alright, here we go. Just pop it in. Shamelessly steal this. Cannot find it. Alright, well, I will patiently read this. All right, I'll abstract this a little bit instead of using the variable for sources. I'll just throw this in. Boop. I don't think that won't need quotes, right? Nope. Target property CUDA separable compilation on. We'll take this out. Target. Yep. C make project name. Separable compilation. I didn't even know CUDA ran on Apple products. That makes sense. I know some of their old Macs have NVIDIA chips. Let's see if let me just try make. I do have make. But can make, yeah, so if I set the compiler to, I set the C++ compiler, oh. I can set the CXX environment variable. I'll just set that to the msvc, msvc.exe, and I can just set this to the mvcc. That's one way to do it. Oh, this is with the GUI. I don't want to use a GUI. Okay, I'm going to try that first, and then come back to this. MSVC. Where's the compiler at? The C++ compiler. Location. Is it anywhere in here? Oh yeah, I can search here. Where is MSVC? Oh, you just link it to the CL.exe. All right, so to copy this path. Just found out the shortcut. Hold on Shift, right click, and copy as path. Okay, so in system properties, variable value, boom. Cut the path. Now I wonder if CMake can use these Windows things. These, the Windows directory delimiter. I'm gonna say no. Alright, then exit the, kill the terminal. There we go. Alright, we got that in there now. Okay, so maybe it says something specifically about building in building in Windows specifically. Oh, by default, separable compilation means you can link between functions in different compilation units. That's really weird that that wasn't supported at first and it took till version 5.0. So you couldn't call a function unless it was defined either in your header or your CU file. I'm guessing you could still like forward declare a function and then later define it. I'm sure it could do that out of order as long as it's within the same compilation unit. Okay, let's see. Start from the top. Okay, so this is just a library. Oh no, they have a executable and a library. And they link in the library, okay. I wonder if Ninja will support just linking it to the MSVC. Here, I'll also just add the path to the to the Visual Studio compiler to my path variable, just to be safe. It's already there. The hell, I got a zip file in my environment variable? And it's still... Let's just open this one up. Oh, 739. Control G, 739. Let's see what conditional are we in? Oh, it's a function. Okay, if compiler ID requires success. Okay, that means if we have to have the compiler ID, then fail it. So if there's a result and we have to have the compiler ID, then it fails. Oh, if the result or the compiler ID output matches warning number 5117 bad P processor line, then we go into this conditional. Okay, so you go to the CMake error log. Oh, there's nothing there. Okay, the output log. CMake cxx compiler id.cpp. That's passed into cl.exe, and then here's our link. Link.exe. Which gets passed in a bunch of libraries. Alright, so yeah, the CXX completed. Created an executable. Then Visual Studio project is created. Then I built the C file. Linked it, succeeded. Alright, it's pointing to the executable, and then it says it creates a Visual Studio project file. And it knows it's built by MSVC from that executable file, and then the log just stops. And the error log has nothing. What? I want to see what it's saying about MVCC. I got a sore throat today. Okay. Created an unsuccessful build file. That's gone now. Ooh. Oh no, it is here. Just in a weird directory. Platform. C users, repo art, C make, file IDs, CUDA. It's just the file's empty. It's filling it for debug. Oh, sweet. List all of the possible like MVCC options. Fast math, line info, no. Debug info, true. I'm just curious. I'm gonna set this to CMake build type to release. I think it's just only capitalize the first letter. Let's try that out. Then if I come here, oh, it's similar to a debug folder. I kept all the debug info on. That's alright, we'll look at that later. Oh, it's billing it for 52. For 5.2, the not CUDA 5.2, but the architecture version. I think. Let me check what version I have. I've got a gaming laptop here, so we got the 1660 Ti in here. Architecture name based on the Turing TU116 chip. SM Arch. I think there's a wiki article. Wiki list of NVIDIA streaming multi-processor Arch. Okay, compute capability. So we get the 116, TU116, 7.5. So I'll just try targeting that. This isn't gonna fix it, but it should make it run a little faster. Reduce the code size, only built for one arch, 2. Let's go here to this directory, saying at this specific line it's not can't find that toolkit directory. Alright, we got the path. We go here. Whoa, slow down there, Nelly. I'll just copy all this in. Boom, 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 boom. CUDA 12.0 dot targets. Own with code. Line 606. If does not exist, but it does exist. Should I just define it like right in front of here? Why am I even in this folder? I feel like CMake should be smart enough. Log CUDA toolkit. We'll search the whole directory for this. Whoops. How do we make paths in here with the proper format for Windows? So if it has this message here, it should be logging this somewhere. It's okay, I'll just grep the entire system. Because I'm crazy. Good time for a bathroom break. Maybe I should just make this in Visual Studio for now and then. No, yeah. Oh, I know what I'll do. I'll just gut out the working projects, all of its directories, and just put my one file in. And take this out. What could it be doing differently between these two? So it won't run this. CMake. I'll take this out. Guess we're not that serious. CXX. Set the C++ compiler. We got that in here. Boom. Oh. Oh. It's because there's a lane spaces, so it next lines. CMake build type. None of this is set in this file. Oh, it does have this in here. Control KU. What if I just made it find OpenGL? We shall spare no similarities. This is all OpenGL stuff. Include directories. Link libraries. What if I did separate these? Properties. Sure. Prepare for build. Create the T-log. There we go. I'll just put a message up. Let's see what the see what it says. Alright, we'll see the result and the output. Retry admin, yes. But there's like no way this is correct formatting. Let's try this again. See, I'm using OBS Studio to stream, but I can't see the YouTube chat messages in it. I could earlier. Settings, general, stream, YouTube. Oh, there you can open it. I'll look it up later. Or will I look it up? Continually. I'll look it up later. You know what? I'll close down VS Code. I'll reopen it. Oh, here it says I can set CUDA toolkit root.dir. See it. Right, open up code, open the folder, just had this one. Oh wait, maybe I can do that scan for kids thing. AI art generator. Scan for kids. It's only saying 2019, which I have uninstalled. Okay, but either way, I'll set this to here. Maybe this. This is not like a C. This doesn't start with C make. Oh, we'll see. It's gonna work. Oh, we found it! How the hell? Okay, still an error. Oh, it's just the compile options there. At 49. CMake project name. Oh, it doesn't have. Oh. Let's fuck it. I'll just put that there. Oh my goodness. Okay, so this variable must like downstream somehow because that other file we were looking at, where was it? This one, this is a Visual Studio file, and that's the one that was saying it couldn't find the CUDA toolkit directory. But there must be some phase where CMake takes this variable, CUDA toolkit root-dir, and translates it to that. Oh my goodness. Okay, so fix the compiler thing. Can't find the main.ccp or .cpp. That is fine, because that is a main.cu now. If you see me, see you when I see you. I gotta get rid of this, all this OpenGL stuff. I think I put 3 OpenGL. Yep, here's the third one. Alright, this should be good to go. Build files version. Alright, okay, so I should be able to go build folder. I'll just open up the solution here. And we'll build it after it opens. Yep, I should get rid of these. Back to stock. Oh, we don't need it release. Build. Build. All right, it is built. So, yeah. So, all right. Command prompt. Boom, paste in that executable. Hello, CUDA. My goodness. Okay, so then if just run it again. So if I take this off, did not work. Oh. Oh. It's still working. Was it that scan for kids thing I did? What does that do? Does that like modify environment variables? Let's see if there's anything new in the path. No. I mean, I wouldn't do that anyways without user account control. Oh, there's these now. I don't know if those were here or not before. Well, I mean, I guess I could check my stream. CUDA path. It just has it like a normal variable. I'm going to delete these. Cause I'm crazy. I'm a madman. That's right, I'll threaten this whole project. Delete. Delete. Kill terminal, restart it, and let's see if it works. This is still coming right out. Still found it. Okay, and now it's now it's back. It's like a boomerang. Like one of those cursed dolls. Okay, I did. Okay, delete, delete. Okay, come back. They're gone. I'm safe. No. I don't shut down the terminal. Well, it's still gonna be there. Not gonna mean anything, so. I guess I'll check it though, anyways. Alrighty, environment variables. Yeah, it's not there. Okay, so kill terminal, boop, boop, and run it. Found it. It's gone. It's actually gone. Now, is there a way through the command line I could get Visual Studio to build this? Now that I have the solution files generated. I know I used to, in my old project here, Jets2D, I didn't have to use Visual Studio. So I don't know. But let's just keep this cross compiling while we're here. So just MSVC all this stuff. What else do we have that's specific to Windows? Nothing. And we'll take the C off because we don't need that. Should be able to make everything faster. Well, you know, when I build this, in Visual Studio, it should like tell me everything it puts into the command line. Okay, so that worked. Come back here, run this. Do I have an environment variable here that's like, tell me what version of CUDA I have? No, so I can't like make a generic CMake file for everyone to download and load and use. Alright, let's make the Git. I don't remember how to do that. Just like get init. Alright, we'll make the new repo. We'll be able to change the name. That's fine. AI art generator using stable diffusion in CUDA C++. Public. Do a readme. We'll do C++. Oh, is there a CUDA one? CU. Alright, git ignore. Licensing. I'll do that later. This will set main as a default branch. Can I just do the whole folder up here? Woo! Yeah, I don't want all these build files in here though. Just kidding. Actually, let's go back. First commit. Commit changes. All right, and then we'll just delete it all. Actually, better safe than sorry. I will. Oh, this. Backup CUDA system variables .txt. Didn't have to add the txt. All right, close that yet? All right, now we can clone it. So git bash here. Git clone. To paste, you got, it's like weird, it's shift insert. Or you just right click. Alright, we gotta check our git ignore because we want to, and we'll always use Visual Studio Code. Git ignore, we want to I have the build folder in there because that's really gonna clog up the git. Stack libraries, we don't need those. Nope. Oh, these PCH files get huge on Visual Studio. Once I had one that was like, or no, it wasn't PCH. What was it? I had a file that go over a gigabyte once in my Visual Studio folder. It was a type of folder, it might have been PCH, but it's one that like, I looked it up, it helps like the autocomplete navigate and stuff so it doesn't have to reparse your whole project every time it starts, but there must have been some kind of crazy bug in it. Alright, so let's save that. So git -m updated git ignore to ignore build folder. Then it'll be saved. Oh. Wait, where does it think I am right now? Oh. CD repos. Okay, now it works like Linux in this git bash CLI. AI, bam. Does LL work? Yeah. All right, so git commit. Oh, control U up, just like Linux. Oh, I gotta log into GitHub. Oh, what am I doing? Git at all. Okay, now git commit. Now git push. Oh, I think I'm gonna do like the key thing. Oh, it's let me sign in through the browser. Hell yeah. I haven't used GitHub in a while. What's going on? It's waiting on something. Oh, it did it. If it really did it, then if I looked here. Woot. And if it really did it. It would generate everything, and if I did a git status, it would show no changes because everything happening is in the build folder. Git status. Yes. Fuck yeah. Alright, guys. This is working. This might even cross compile. I don't have a script yet built so you can build it in Linux, but it's just a CMake and then a make. And it's compiling for CUDA. So in the description, I've got GitHub. Let me double check. No, it's not in the description. What happens if I go to YouTube like from my computer right now? Can I just maybe I can put it in chat and then through the replay people can see it. And the current users can see it, of course. Yeah, I just put it in. All right, sweet. I've got my notes too. Hell yeah! All right, this is a slow episode. I should add some more stuff to this, like the description, in case anyone ever else wants to set this up. CUDA, latest CUDA 12.0 on VS Visual Studio 20.22. It was either the scan for kits through VS Code, or it was just setting this variable once. But either way, it's here. Oh, let's see if fatal error works. That looks. It's so memorable. All right. clean this up a little. Players will go, but yeah, the math hasn't started yet. The math should be fun. The forward propagation, the back propagation, learning rates, number of parameters, and then I'll try to match to like the neural network architecture to like the architecture of my card. I don't even know how many CUDA cores I have. Actually, I'll just check that now. That's a good thing to know. Yeah, I just want to have like. No, I can run my samples. Source. Nope. Where's my samples at? Oh, there's like a Excel occupancy calculator. Oh, I think this is a little dated. I think if you get your register count too high, I think it just converts it to global memory. We'll check. I've got some reading. I'm pretty familiar with Pascal, so like the 1080 Ti, all the 10 series. I know a little bit about Turing and Volta. The biggest thing, eventually, we'll move to either like the Turing with the tensor cores, so the half precision floats, which you can accumulate into 32-bit float. And that's the Turing cards that are 20 series. I have a 16, so I don't have that, so I'm not going to implement that yet. And then once I do, though, we can do that on the Orin. But yeah, there's Turing, Volta, and what's the Ampere's the latest one. Also, I've got a Jetson Xavier, but that one's at work. And the Orin's, yeah, the Orin's Ampere, I believe. But yeah, 30 series is definitely Ampere. Yeah, Orin's Ampere as well. And now they're splitting the architectures again for the data center GPUs. So it's going to be, I think the 40 series 80, and then the servers are a Hopper. I don't know shit about those. Oh yeah, another big change they made is either with Turing or with Ampere, but now the warps are not in lockstep. Like all the threads within a warp aren't guaranteed to be in lockstep. So that's like really going to change people's codes. But you can compile it to an older version of CUDA, and then the newer cards they can run like with them in lockstep, like how all the old code is like written that it's guaranteed for that. I know I have code that will have issues with that new update, but we're starting from fresh here, so we can plan ahead on this project, and I'll keep that in mind. But Pascal's a good generation. It's cooperative threads. You don't have to shut down your kernels all the time. Way cleaner code with cooperative threading. Yeah, plus I've got a 1080 Ti on this bad boy. I don't even use it that much. I mainly just use my gaming laptop. Which is slower, but I mean, they're both so fast, it's like, I can't even tell the difference. And I play Factorio, so don't need a good computer for that. Alright, let's get these samples running. Tools? Oh, check that. Source res sources. It's not res. Oh, when I installed it, CUDA, it said yeah, the demo suite. Here's the demo suite. I figured that was the samples. N-body, that's an old sample. Ocean FFT, yeah, I remember these. Oh, you don't get this. There's no sources? What the F? Well, I mean, I guess you get the. That's so weird. What about 11.3? I uninstalled this. Right. Yeah. I liked having the source. Oh, but they were the source, the sample sources was like this really old coding style. That's good enough though. I mean, it's the old coding style. I'm in the embedded world professionally. Okay, source. Where the hell was I? This extra is demo suite. Oh yeah, if I run it, it'll just open and shut. Yep, that fast. So we'll open PowerShell, hold Shift, right click, PowerShell window here. Device query. 1536 CUDA cores. All right, that'll inform our. We'll make like a. We'll make the neural net be like built for this. I can make it like dynamic enough. Well, I want to say dynamic, but I'll use like compiler flags, like defines, so that I can so the neural net gets compiled like into the perfect size. But then when we move over the Orin or the 1080 Ti, it'll just like be really efficient for the size that it is. Let's see, warp size 32. So I think it's always been 32. But I want to know cores for streaming multiprocessor. That should be 128. I think only Kepler was different at 192 cores per SM. So this would have 12 SMs. Why doesn't it say? I mean, I guess technically it's abstracted from the programmer enough that you don't have to know cores per SM, but it's good. It's good enough for optimization. Let's just look it up. Turing cores per SM. Oh, what? 64? $256 kilobytes of registers per 64 cores? So this has 24 SMs. But this is, it says 8 tensor cores, but that's not on the 16 series. It probably still is like 64 cores for SM. But let's just check this out. 16 series. CUDA is an abbreviation of Compute Unified Device Architecture. That's what that first when it came out, they're like, it doesn't stand for anything. And then they're like, then they said it stands for Compute Unified Device Architecture. But you know, they just made that up. And then like a year later, they're like, no, it doesn't stand for anything. Thinking backwards. They do that shit like that with the Jetson. They called the Xavier Jetson the Jetson AGX Xavier. And everyone's like, oh, the X and AGX must stand for Xavier. And then they came out with the Orin. They called it the Jetson AGX Orin. So my boss asked them, what's the AGX stand for? And they're like, oh, we don't know. Okay, we can just assume it's 64. Okay, number of CUDA cores per S7 is reduced to 64. I'll just assume the 16 series is the same as the 20 series. And it really is only that there's no tensor cores in the 16 series. Or is it just there's no ray tracing cores and there are tensor cores? Are those even different? I feel like they'd both use linear algebra. Okay, so integer and floating point separated in Turing. Okay, so it means they have different pipelines. I thought they had different pipelines on Pascal too, though. Like if you're doing independent, if you're like, I mean, most of the time with floats and integers, it's like independent of each other. But yeah, if you're doing math operations where you've got your floating points and like one array and your integers and another batch of arrays, and you can fire off like say like a division on an integer, which is going to take you like 30 clock cycles, then it can throw the floating point down the floating point pipeline while it's waiting to get the results back for integer. I'm pretty sure it worked that way in Pascal. So you can really squeeze that performance out. So I don't know why it's saying they were separated starting in Turing. Okay, and then Ampere, that's what my Orin is. GA100 had 128 SMs with 10,752 CUDA cores. So wait. Oh, GA100 had 128, and the Ampere GA102 had 10,752. I was gonna say like 128 times 64 is not 10,752, because that's not a power of 2. So there's 2 FP32 processing units per core in Ampere. I guess, okay, I should just read this now because it's in the Orin. Well, it doesn't matter. I'm just going to use almost completely tensors. No, that's not true. At the very tail end of the back propagation, well, I call it the tail end because well, yeah, because it's going back. You will be multiplying the weight times the neuron value of the forward pass. And so you wouldn't use the tensors for that. So you can do independent. independent floating point calculations, both like just one cycle apart. You can launch them off before you get the result back. That's cool. Or you can do one FP32 and one int operation. I don't think I'm gonna do any int operations. I don't know how int 8 works. I keep seeing it, but I don't know how that works. But yeah, that's a really small, just 1 byte. That'd be sweet. Get a huge neural net. I did read some articles on like how going from half precision to int 8, you basically there was no like neural network architecture trained that saw any noticeable like loss in performance. Same obviously then of course from FE32 to FE16, there was no architecture that didn't train to be as good going from 32 to 16. What site is this? Tech Centurion? I haven't even heard of this. They're like going in depth. I'm typically used to this from like a non-tech. I always wanted to experiment putting like just the first layer of your parameters, so like your weights and biases, into the texture memory, because it's read only anyways. Well, for a forward path. Well, or maybe put the last layer in, because then you can use it for backpropagation. For every single backpropagation you do, almost you can use the last layer parameters. So yeah, you put that into the texture memory, because the texture memory is not going to hold like the whole net. But the texture memory is really big. It's just I think when the kernel, after the kernel launches, it's read only. It's super fast is the point. I don't remember if it's the same speed as like L1, but I think it is, or at least close. L1's ridiculously fast. A GPU core cannot fetch or decode instructions, just carry out calculations. But then how come they're not? How can they not run in? Or how come they can run not in lockstep now? Like within a warp, they would. Oh well. Okay, yeah, maybe there's a cache of like the decoded instructions coming in, but there's like a huge list of them, and so then they can only get so much out of lockstep because they're all being fed from the same instruction cache. Okay, I might as well just like think this is all true. It's like too much work to like doubt it. Except that he was wrong earlier. Maybe it wasn't wrong earlier. Maybe I just wasn't thinking of it properly. I remember I thought he was wrong here, but he wasn't. But I mean, I don't know for sure. But he probably wasn't. Where was the part where he was wrong? Maybe me thinking he was wrong here threw me off. It was like biasing me on top of that other part where he was wrong. I don't even remember where he was wrong though. Oh, the integer and floating point were separated in the Turing architecture. That's what it was. Maybe he is not wrong about that, but I'm pretty sure he is. Let's just look it up. Pascal architecture. Floating point pipeline, integer pipeline. Okay, NVIDIA Turing architecture, technical deep dive. $83-page white paper. They probably took it from the white paper. The white paper is not going to be wrong. Let's look at pipeline. Integer and floating point operations can now execute concurrently, whereas Pascal would suffer a pipeline stall when integer operations were calculated. Turing has independent data paths. And one would block the other when queuing for execution. FPUs often sit idle in Pascal. Okay, well, okay. I thought, because I took the Coursera course from NVIDIA on CUDA. That was years ago, though. So Turing has a 64 FPUs. Per SM, but then but on Ampere, there's 2 FPUs per core. But you can't run the 2 FPUs and the integer units all 3 at the same time. You run 2 of the 3. I don't know, wonder Ampere is like so much faster. Yeah, so each core is like 2 cores. I don't think I'm gonna use integers at all. Well, I mean, besides like clocks or like counters, and yeah, like for loops. Well, oh yeah, indexes. Duh. Yeah, that'll be nice. Having all the indexes run in parallel. Well, not like they'll only have to wait like one cycle to launch if a floating point's at starting. I guess I shouldn't read like the Ada or Hopper architecture yet. Well, I could read the Ada one. I could get a 40 series card. I read the Volta a while ago, so that's gonna be similar to Turing. Oh, maybe that's what I'm thinking of. That Volta had like the concurrent editor floats execution. Well, I'm getting tired. But yeah, I've got to read the Turing GPU architecture definitely before we start the even the forward propagations. So I'll just do that, and then I'll forget about Ampere for now until we move to Orin. I'll read that. Yeah, once this thing gets fast, I might as well get like a 4090. That'd be sick. But my computer now is water cooled. I'll probably have to get like a new motherboard in case. And I don't know if I'd want to water cool it again. I do love the water cooling though. It was a pain in the ass. When I first got it, I just got all the cheapest water cooling components I could, and it's like leaking everywhere. So then I just gave up and I bought like just like the highest end water cooling components I could get, and that even leaked, but then it stopped, and I've moved it in many U-Hauls, and it's been good to me. But man, that was a pain in the ass. But there's so many times I've been working or sitting at my desk and I just look over at it and I get that looks good feeling. So it's worth it so far. Oh, it's worth it all the way now. Man, how big of a radiator do you need for the 4090, especially if you're gonna cool the CPU? Radiator size RTX 4090. Yeah, and I am stuck on NVIDIA. I've got so many of my projects are in CUDA. But last I checked, there was a paper 2 years ago that CUDA is faster than Vulkan anyways. By like 10%. 2 360 millimeters? Damn, I got one. I do like how quiet the water cooling is too. So I wonder how loud the air cooled 4090s are. You need all the rads. Damn, this guy's saying 3x 360 millimeter rads for the 4090. I don't think so. You might as well pull a radiator out of a Volkswagen at the junkyard, like an old Beetle or something. For real. Wait, let's look this up. How much is a... Okay, AutoZone.com. It can't be that expensive. 19... You'd want it to be like a similar metal to the block, so you don't get like the dissimilar metal like corrosion issue. Volkswagen Beetle radiator. Actually, you probably just get one of those aftermarket like Chevy 350 ones. I'm sure it'd be really cheap. There's so many of those modded 350s. Radiator. Oh, they're are these air cooled? Oh, it's spelled. It's actually spelled how you would spell beetle, unlike the British rock group. I guess some people in Europe can spell. Is VW Beetle, whoops, air cooled? It was air cooled. And it was in the Porsche 911 too? What? How much horsepower did it have? Damn, there was an air-cooled Porsche 911 Turbo with 450 horsepower. That's crazy. I feel like you'd want to like warm it up. Because if it's air-cooled, I feel like it's going to heat like the outside versus like closer to the combustion chamber is going to heat at like such a different rate. Like if you're just like on the throttle really hard, like when the engine's cold, that you like crack the block or something, or you know over time at least. Oh, okay. That 911 had an oil cooler. Still though, you'd have like the whole top of the block. I mean, it gets a little oil up there. And then what are the 4090 prices? I know they MSRP for 1500, I think. we look at the MSRP. $1,600. Sort by lowest, and we'll do buy it now. $1,900. Oh, they're still being scalped. I figured that Ethereum proof of stake is gonna kill them. Kill those scalpers. Yeah, that's expensive. But it's not like I'm gonna finish this project tomorrow, so I get probably a long time. It's a 24 gigabyte frame buffer. Wasn't that the size of the 3090s? Yeah. What? They're $775 right now for the 3090s with 24 gigabytes. We'll check the profiler, but I'm pretty sure it's gonna be mostly like memory constrained. What would you call that? Like memory bound or memory latency bound? So I don't know if we're gonna check the bus width and the generation, like the GDDR, like the latency specs on it, but it might not even be worth it to get a 4090. Damn, because I could get two 3090s and like another card like for the price of a 4090. I got an 850 watt PSU. But yeah, the frame buffer size would limit the limits the size of the net. Like it's not like you can just keep writing it back to the CPU RAM and then taking it back. It's like a huge PCIe latency. I mean, yeah, that'd be ridiculous. It'd be better to have. I mean, you still have this PCIe latency going from one card to another over PCIe. But I was thinking if you have two, if you put the two GPUs into two PCIe slots. Actually, would you have more latency transferring data between those two? Like, because will it have to go through the PCIe root complex? And then use that use the DMA on the root complex anyways, so on the CPU. Oh, but the throughput's like way lower on the CPU RAM, so I mean, obviously it would be better to just have a huge frame buffer on just like one GPU. So yeah, we can profile it. So we'll run the project on. We'll run it on the GPU, on like the 1660 Ti, and then we'll look and see if it's compute bound. In which case you get the 4090, and if it's just like severely memory bound, then just might as well get the 3090. But I'm betting it's memory latency bound. Starving those cores. I'm getting tired. It's getting late. Alright, everybody. Thanks for watching my first stream. We'll continue tomorrow. We got the frustrating part dealt with. We could just take off from here. Yeah, let's just do that. We'll just hop into deep learning. I don't think I'll stream tomorrow, but I'll be streaming on Saturday. Alright, bye guys. Oh, I got one thing to check before I leave. Okay, I checked it. Bye guys. Have a good night.